Hello, I'm Anna Mackay, and this video is part 2 of discrete probability distributions. So our example to start with, 2 marbles are randomly selected without replacement from a bag containing 5 pink and 3 blue marbles. Let X denote the number of pink marbles selected. So pink marbles are like our success, they're the ones that we want. Now, whenever you get asked to find the probability distribution of X, that's asking you to draw a table of the distribution of the probabilities. So how the probabilities are distributed across the different outcomes, and the outcomes being the number of pink marbles selected. Also just thinking about what this section's called, that's probability distributions here, as you can see at the top. So how probabilities are distributed for discrete scenarios. Now, back on our previous videos, we talked about what is a discrete variable. Discrete means that you can count or measure it. It was count. So in this case, we can count the number of pink marbles that we select, and we're going to look at how the probability of each of the scenarios are distributed. So that's what we're doing. So to do that, we need a tree diagram to then help us draw the table. So our tree diagram, let's start with we're picking 2 marbles. So the first scenario that could happen is we pick a pink or a blue, and then next time round a pink or a blue and a pink or a blue, pink and blue. And along each of the branches, we're going to write the probability of each of them happening. So first time round, 5 pink or 3 blue. So how many marbles in total? There are 8 choices, so the chance of getting a pink is 5 out of 8. So therefore the leftover ones must be 3 out of 8, because that's 3 blue ones. Now, we don't replace them, so we've picked one out and put it aside. So there are now one less marble per bag in the bag, so that's 7 we've got left. So the chance of picking another pink one is how many out of 7? Well, this branch assumes we have already picked 1 pink, so that now there is 1 less pink, which means there are 4 pink marbles. What about the chances of selecting a blue on the second go? Well, in total there are 7 marbles, but there is still the full total of blue, so there are 3 blue marbles following this branch. The last 2, so we've got 7 marbles for each of these branches. What are the chances of picking a pink on the second go, assuming you've picked a blue? Well, we still have the full quota of pink marbles for this branch, so that's our 5 out of 7 in total. And for our blue, we've got 7 marbles in the bag. We've already selected 1 blue, so there's 1 less blue, so there must be 2. Okay, now let's think about what we end up with each of these marbles. We've got 2 pink along this branch, a pink and a blue and a pink, and 2 blues. So what are the chances of, or the probability of getting to the end of each of these branches? To work that out, you have to multiply along the branch. So this branch, we have 5 out of 8 times by 4 out of 7, and I can tell you that gives us 5 out of 14. I'll tell you what the other branches are. We've got 15 out of 56, 15 out of 56 here, and 3 out of 28. Now, just noticing that this gives us our X is equal to 2, so this is the chance of getting 2 pink. These give us the chance of getting 1 pink marble, and this is no pink marbles. So we've now got our probabilities to put into a table. I haven't left myself much room here, but nonetheless, we'll make do. We'll do it up the top here. So whenever you draw one of these, you put a little x there, and this is the probability of capital X of choosing any one of the different scenarios, the little x's. And our options are 0, 1 and 2 pink marbles. And into these probability sections, we put the probabilities we've just calculated. 0, we've got 3 out of 28. 2, 5 out of 14. but it's worth noting that the probability to go in here is the sum of these two. So perhaps I'll just put a note that that's PB plus BP, and I'll tell you that that comes out to be 15 out of 28. So that's how we drew up our table. Working with that a bit more, so here's the table there that we've just written on the other page. We need to find the mode and the median of this distribution. So this is the probability distribution. The mode is the one that happens the most often. If it's in decimals, it's really easy to see. Sometimes it might be worth noting that that one is 10 out of 28. So they've all got the same denominator, and then it's fairly easy to see that the one that happens the most often is 1 pink marble. So then we would write mode is equal to 1 pink marble. And the median, as we did on a previous video, but good practice to do it again here. So how to work that out though? The first probability of getting 0 pink marbles, is that the median? Well, let's have a look. The probability of that is 3 out of 28, and I'll tell you as a decimal that's approximately 0.107. We have to keep adding them up until we get to 50%. So we're not there yet. Let's add up 1 and 2. So the first probability and the second probability. Hang on, that should be a 3. 3 out of 28 plus 15 out of 28. I'll tell you that's approximately 0.643. And because we're now over 50%, 0.5, therefore the last one that we added on, the second probability, which is this one here, 1 pink marble, that is our median. So 1 pink marble is the mode and the median in this case. Next example, and our last one, showing that the following is a valid probability distribution function. Occasionally you'll see things like this. So this is a function, and just like in our table that we're used to seeing these different values, we're going to substitute these in to this function and see if it holds true. So what we do is we have to input each and every value. So we're using these 5 values here. So where you see an X, we're going to put in a -2. I'll just show you for the first one in detail that that's going to give us that function. So we've got 4 out of 10. And then we put that in for all the others. So the probability of getting -1 is 1 on 10. The probability of, getting 0 is 0 on 10, so that's 0. The probability of +1 is 1 on 10, and the probability of +2 is 2 squared on 10, 4 on 10. So to test if something is a valid probability distribution, it has to meet these properties. So every probability needed to be less than 1, greater than 0, greater than or equal to 0, and it is. So the way we write that up is we say that the probability of each individual element there is between 0 and 1, and we say in each case. And the second part, we have to test this, that the sum of all the probabilities is equal to 1. So the way that you write that is you draw that summation notation sign, n at the top, I equals 1, because that's where we're starting from. So of individual values here, we add them all up. So those 5 values we add up, and as you can see, we will get a total of 1. So to finish that off, we say therefore P of X is a valid probability distribution function. P of X is a valid probability distribution function. That's how we finish that off. And that's the end of this video. If you liked it, give it a thumbs up and subscribe to the channel. And the next video in this series is called Expected Value, and it's 3 parts. So part 1's the first one. Thank you.